All right, we are back here at adding and subtracting rational expressions. I've got a few guest people that are going to say hi, so go ahead and say hi, you guys, really loud.
Hi.
Yeah, now you're famous, forever immortalized on Mr. Newbold's videos. And should we say who it is or no? Should we do name shout out? Yeah, it's Boston and Tim. Woo! All right. So let's see here. I think we already did number 1, most likely in class. So let's see here. Let's see. Well, we could still put it on there just in case. I think one of my hours didn't get to it. So let's see here. So number 1, we already have the same common denominator, which makes it easy. We just do 16x squared. And then we just combine the tops on one line. So 3x minus 2 plus x plus 4. Put them all in one line. Then we want to combine those things that are the same. So 3x plus 1x, you're right, is 4x. And then 4 minus 2, so 4 with the negative 2 is just 2. Now some of you thought this was the final answer. However, it turns out that when all 3 terms can be divided by something, then we should do that and reduce it. So divide by 2, divide by 2, divide by 2. And so we get 4 divided by 2 is 2x. Good. 2 divided by 2 is 1. And 16 divided by 2 is 8. So we get 8x squared there. You could put the exclusion, but they're all going to be the same, that x doesn't equal 0. So you don't have to. It's okay. So that's our right answer. And then we'll go ahead and pause it there for a moment. Okay, so that worked there. Number 2 as well. So let's see here. So we have x plus 5, and then plus a 3x minus 5 all over 36x. So you can notice there that I didn't have to multiply the plus through because it wouldn't change the signs. So plus is okay. We can just set that up pretty easy. So then we just do x and 3x is 4x. And then 5 plus a 5. Ooh, that's a negative 5. So 5 plus a negative 5 is just 0. So then we end up with just a 0, so we don't have to put it down. So it's just going to be 4x over 36x. The x's cancel, leaving us with just 4 over 36. And that reduces by 4. So that's just going to be 1. 36 divided by 4 is 9. So 1/9. Cool. We should probably look at a subtraction one now, because those ones get kind of crazy on us. So we'll look at number 5 next. So now the subtraction is okay. And so the subtraction actually affects the whole thing on that second part. So what I mean by that is we do x minus 2 subtract x minus 3 in parentheses. Because that subtraction is to mean subtract x as well as subtract the negative 3. So we're going to have to put it all over the same denominator, 30x. So we're actually going to have to take that negative, it's an invisible negative 1, but take that negative and distribute it through. So we get x minus 2 minus x, because that changes the sign to minus, and then a plus 3, because negative times a negative is a positive. All over 30x. And then, whoa, that's crazy. The positive x minus x, those cancel each other out. And then the 3 with the negative 1, just like adding those together, is 3 minus 2 is 1. So we just end up with a 1 over 30x. Cool. Okay, we're back there. So cool. So that's how you do subtraction. Make sure that you take that minus symbol and just make it a minus x, a minus 5 with your x plus 1 all over 12x. And so, like x and then x negative x goes away. And then negative 5 with the 1 is negative 4. And so just make sure you change those signs with that negative symbol there. Yeah, make sure you change those signs. So then that reduces to negative 1 over 3x. Cool. These aren't too bad. So just make sure with those negatives. We'll jump to the back side because I know these ones look a little bit tricky there. So maybe we'll do number 11 with you. So let's see. What is this? Actually, I want to do Yeah, those ones I think you'll be okay with. Just multiply by an x squared. Multiply with an x squared. You'll be able to handle that. What about this cool, crazy one, right? What about this one? Well, let's see. That's missing a common denominator of 4x. So if we multiply the bottom, so this is the same as 1 over 1. So then if we multiply the bottom with, multiply it with 4x on the bottom. So multiply it there. And then multiply the top with 4x. I think that'll help us, won't it? So then we get 3 minus 1 times 4x is 4x all over the bottom, which they both have a denominator of 4x. So we'll put that there. And then cool. It wasn't too bad. It just looked kind of weird, huh? And then they can be divided by 2. Nope, the 3 can't be divided by 2. So that's just your final answer there. Cool. And so I think you'll be okay with the rest of those. We'll do, let's see, a graphing one. Ooh, this one looks really good, number 16. I bet you'll ask for that one in class. But I'm thinking that you'll have to multiply this by an x. Yeah. And then we have, oh, this is tricky. So this needs a 2, timesing it there. And then, ooh, these also need another x there. Whoa, that's crazy. To be an x cubed. So we get 2x cubed is what we're looking for. Trying to get 2x cubed is your hint there that you're going for. So I'll let you finish that one with number 16. I think number 18 we'll do on the video here. So that factors into x and x, 1 and 3. We need to be negative, so that goes with the bigger number. Good. And then the top, I think we can factor out a 2x. It's like single factoring. So that's going to be let's see. So a 2 comes out, and then just left with an x. And then 6 divided by 2 is 3. Cool. So once we factor that there, then the simplest form would just be the x minus 3's will cancel, leaving us a whole at x minus 3, leaving us a whole there. And so set that equal to 0. We get x equals 3 as our whole, actually. So that x minus 3 goes away, leaving us with the simplest form of just 2x over x plus 1. Nice. And so to find the y-intercept, we set x equal to 0. So that goes there and there. And that's just going to be 2 times 0 is just 0 over 1. So the y-intercept when x equals 0, y equals 0. Cool. And then we'll take that back. And now we have to set x equal to 0. No, we already did x equals 0. Now it's set y equal to 0. And so when y becomes a 0, and we multiply both sides by x plus 1 to both sides, and the x plus 1 times 0 is just 0. So then we have 2x equals 0. And so then we divide 2 to both sides, and we get x equals 0 over 2 is just 0. So then x equals 0 when y equals 0. Oh yeah, duh. So then we have, whoops, put that there. So then we have just same place at the origin. Cool. That's kind of cool. So then we want to do our vertical asymptote with our simplest form. So our simplest form, Ant-Man. All right, there we go. So now to find our vertical asymptote, we set the bottom equal to 0. So we get x plus 1 equals 0, which is just x equals negative 1. Cool. So then we go to negative 1, and we do a nice asymptote there, hopefully better than mine. The horizontal asymptote, so yeah, so it looks like here in both cases, the powers are the same with the original and with the simplest form, and they both have the number 2 over the number 1. So 2 over 1. And so that means our horizontal asymptote is just going to be y equals 2. So we go ahead and do a horizontal asymptote at y equals 2. And then let's see here. So now we want to graph it there. So I can see that the x-intercept was at the origin 0, 0. And so more than likely that means that this is just going to come up and go through that origin to the right. And if that's the case, then I'm going to guess that this also comes up this way. But we should do a test point just to check it out. So how about a number less than our asymptote? Our asymptote was negative 1. So a number less than negative 1 would be negative 2. So if we plug over here back to the original equation, and everywhere we see an x, we plug in a negative 2 over x plus 1, or negative 2 plus 1. We get, whoa, that's weird. Oh, 2 with the negative 2 is a negative 4. Cool. And the negative 2 with the positive 1 is a negative 1. Right? Right. So then that's negative 4 over negative 1 is a positive 4. So then at negative 2, we get a positive 4. So at negative 2, we get a positive 1, 2, 3, 4. 1, 2, 3, 4. Yeah, so the graph does come up there. Because we did, so that's called doing a test point, right? Yeah, doing a test point with an XY table, that's a good idea. So then, so that's right. So the domain is all real numbers except for our x asymptote there at negative 1. So we say all real numbers. And then Dayton showed me. What's up, Dayton? Shout out to you there. That we need to have real numbers looking like a dat. You can even put a little line connecting it. So that's all real numbers. And so except x can't equal our asymptote there, because that would be a problem at negative 1. Doesn't ever touch it. So all real numbers except x can't equal negative 1. And then the range is all real numbers except y can't equal. What number was this one again up here? Wasn't that a 2? Yeah, there it is. It was our horizontal asymptote. So all real numbers except y can't equal 2 because it's an asymptote there. Cool. So thanks for watching. Hopefully that helped you. And so this will be due coming up pretty soon. So go ahead and get it done. Finish the rest of it. And thanks for watching. Take care. Bye for now.